This project is using a dataset by the UK government which outlines the road accidents which have occurred during the period of 2012 to 2014 in the UK. The dataset also contains many relevant fields relating to the accidents, such as the number of casualties, the day of the week it occurred on, the weather condition, and whether it occurred in a rural or urban area. The motivation behind this project is to discover when, where, and what the conditions were in the majority of accidents which have taken place. This is to find out what conditions provide the most risk for road users. This data can then be used to allow drivers to identify the most appropriate time and conditions to travel in, to be able to limit the risk of an accident occurring. The dataset includes a vast amount of data relating to the car accidents, with 10 columns of relevant categories including the data of over 400,000 road accidents. The data gathered on each of the accidents contains the number of vehicles involved with the accident, the number of casualties the accident caused, the date the accident happened, the day of the week it occurred on, what time it happened, the road type that it was on, the speed limit of the road, the lighting conditions, the weather conditions, and whether it occurred in an urban or rural area. So using that data set, I set out to answer some questions. The first being, how does the speed limit affect the number of casualties per accident? And how many more casualties would occur if the roads, which had a 70 mph speed limit, increased their speed limit to 90, provided that the amount of accidents remained the same? The second being, do more accidents occur in rural or urban areas? The third being, which day do accidents occur the most on? The fourth being, which types of roads do accidents occur the most on? And the fifth being, what is the correlation between the amount of cars and the amount of casualties? Excel was used to manage the data because it's an expansive program with many tools available for it, including pivot tables, graphs, and equations. Now let's move on to the first objective, which was how does the speed limit affect the number of casualties. This was done by creating pivot tables which find out the average number of casualties, the sum of the number of casualties, and the number of accidents per speed limit. The graph was then made comparing the speed limits with the average number of casualties, which showed a positive correlation between raising the speed limit and the average number of casualties. A trend line was then used to calculate how many casualties on average would be caused if the speed limit was raised to 90 miles an hour, which was approximately 1.81. That was compared against the 1.57 average number of casualties in a 70 miles per hour speed limit. It was then calculated that providing that there was the same amount of accidents in the past 3 years, it would have caused an additional 7,000 casualties if all the 70 mile per hour zones were increased to 90 miles per hour, meaning that increasing the speed limit would increase risk. The second objective was an analysis on whether more accidents occur in urban or rural areas. This was done by comparing the amount of accidents in urban areas to the amount of accidents in rural areas and creating a bar chart for it. And as it shows, there are almost twice as many accidents occur in urban areas that compared with rural areas. Which means that if someone has the option of either going through an urban area or a rural area, it's a lot safer to travel through the rural area. The third objective was an analysis on which days accidents occur the most on. This was done by creating a pivot table with the days of the week and the amount of accidents which occurred on each of them. It showed that the least amount of accidents occurred on Sunday, and the most amount of accidents occurred on Friday. So if someone has the option of either travelling on Friday or Sunday, it is much based on the fact that there have been 24,000 less accidents on a Sunday compared to a Friday in the past 3 years. Objective 4 was an analysis on which roads the accidents occur the most on. This was done by creating a pivot table, including the types of roads and the amount of accidents which occurred on each of them. And the analysis showed that vastly more accidents occurred on single carriageway roads compared with dual carriageway roads, roundabouts, or any other type of road, with 325,000 accidents occurring on single carriageway roads, compared with 61,000 which occur on dual carriageway roads. This shows that someone would be safer taking a dual carriageway instead of a single carriageway road. And objective number 5 was a comparison between the number of cars involved in an accident and the amount of casualties. This was done by putting the number of cars and the average number of casualties into a pivot table, then putting it into a line graph which displayed a strong positive correlation between the amount of cars in an accident and the amount of casualties that occur. And it shows a correlation of about 0.3 additional casualties caused by each car involved in the accident. So the more cars involved, the more likely there are to be more casualties. So we can conclude that increasing the speed limit to 90 miles per hour would produce more casualties. The safest day to travel is a Sunday. Dual carriageways are safer than single carriageways, and rural areas are safer than urban areas. While the analysis contains a lot of information on how to avoid an accident whilst driving, it could have been improved by adding additional data on all of the accidents, such as the weather and lighting conditions, and they could have been used to find out which are the most dangerous lighting conditions and which are the most dangerous weather conditions.